Hey, recording is rolling. It is Thursday, December 7th. So we need to do the other half of that AP classroom that we started a few days ago. Only got halfway through it, so I want to finish debriefing that with you guys. You guys remember your chapter 8 puzzles are due tomorrow. It looks like these. We've gone over in class like how to solve them, but I'll pick this up from you guys tomorrow. Or some of you guys probably already turned them in. And then your guys' quiz is due on Monday. Handed out yesterday. If you weren't here yesterday, then it should be on your desk today. Okay. So everybody's got that. All right. Right before I hit AP classroom, I'm doing an extra activity with my honor students, so I want to show you guys real fast. Here, it's kind of the premise here. Guys, this calculator right here. This has probably like more computational power than anything. Let's say the engineers had back in say the Apollo project, right? We're sending astronauts to the moon. They don't even have anything like this, right? Guys, what kind of calculator were most of the NASA engineers working with back in the 1970s? Like those slide rules, like a slide rule, right? So it was like this ruler looking thing. So I tried to find them. I don't know if they manufacture them anymore. They're kind of hard to find, right? They just like slide them back and forth, and you can do multiplication, division, square roots with these things, right? Well, I did find a circular version of this. If you want this, there's a template. You can have it or not. It's up to you. But there are plenty of these around, right? So this is on your desk. If you want one, you can cut this out. There's also a stack of paper clips. So this one I've got put together. I just style a paper clip in the middle, and then it can spin. You guys see how it can spin? So this is basically a slide rule. Only I think it's actually a better design because the fact that it wraps around circular, right? And the numbers are like, how do you use this? I'm giving you guys a real fast crash course so I can get to AP classroom as fast as I can, right? But the numbers are spaced logarithmically. So like, guys, what's halfway between like 0 and 10? You can say 5, right? Now that's in a linear sense. But what's like the halfway in a logarithmic sense, like multiplying, right? That's like 10 to the power 1/2, the square root of 10. Guys, what's the square root of 10? Yeah, about 3.16, about, right? Guys, watch what happens. Right. So if you just focus on one of these circles, you don't even need both of these. Just like focus on the L1, for example, right? Now the 1 represents 1, 10, 100, 1,000, right? So you can like flip the decimal place, right? Well, halfway logarithmically, that's like 10 to the power 1/2, like square root. That's like halfway around the circle. Oh, look at that! It's like 3.16. There you go. Right, that's exactly opposite, right? You can also do like cube root, similar idea. Right? Now, why are there 2 circles then they slide? Right? What's that feature about? You can use that for multiplication and division. What you'll notice is that both rings have numbers that are spaced logarithmically, right? And interestingly, you can slide this around, and the ratios of any sets of numbers are the same all around. So here, for example, if I have it turn like this, right? 2 over 1. If that was a fraction, 2 over 1, that's equal to 2. That's true all the way around. Look, 4 over 2, 6 over 3, 8 over 4. That's all the same ratio, right? But what's this about? 1 over 5, that's 0.2. But remember, you can float the decimal place. If this was a 10 instead of 1, 10 over 5, that'd also be same ratio. Is that right? It works all the way around. 1.2 over 6, that could be 12 over 6, right? So you do have to be aware that you can like float the decimal place, right? Now, the fact that all the fractions lined up, and you can rotate them and still get the same like ratio all the way around. I just happen to have a 2-to-1 ratio, right? Well, you can pick any sets of ratios, and you know they're equal. So, for example, 2 over 1 is equal to 6 over 3. I'm just doing a real basic example, right? That'll be true, right? And if that's true, then you could do cross multiplication, right? Like 2 times 3 equals 6 times 1, right? Now, that you could really take advantage of because this 1 right here, 1 times anything is just itself. 1 times 6 is 6, right? Oh, that means that whatever this yellow inside 1 is pointing at, well, in this case, it's pointing at the 2, right? That number multiplied by the inside number anywhere else is equal to the number sitting above that. So like 2 times 3 is 6, right? So here. So if I look at this 1, which is pointing to the 2, and I go over here and say, I wonder what is 3 times 2. Okay, do that 2 times this 3, and the answer is 0.6 right there. Okay, and you can do an opposite process and divide. Right, guys, that right. And if you want to multiply anything else, what if you could just like rotate the circles, right? So let's do something crazy. What if I wanted to know what is 3.7 times 4, right? I don't know, just something crazy. What is 3.7 times 4? Well, according to this, it looks like about 1.4. It's pointing pretty close to. Now 3 times 4 is about 12, so I'm gonna roll the decimal place and call that about 14. I just made that up on the fly. I don't know what the answer is, but let's find out. 3.7 times 4. Let's see how close to 14 that is. 14.8. Okay, so not too far off. Okay, right. So you lose a little precision with this. It's not as precise as the digital version, obviously. But all right. So if you want that, there you go. I'm going to switch over and let's debrief the rest of that AP classroom.